to this talk. And I'm gonna remove my earphones because I did not figure out yet how to record your voices. Can you still hear me?
Yeah,
all right, so teaming up. I want that to happen because personally, it's physically impossible for me to grade 70 lab reports every single week. You know, can you imagine how crazy it is? And I want to try to be punctual for the 10 labs. I'm talking about your class and the other classes that I have. But the admin is not being able to be convinced about this. And I need to tell you that lab number 3 is gonna be a bit long. Later on, the labs are gonna be a little bit shorter. The admin does not want us to do any group work for many reasons. And the top reasons, Ratib, it's okay. So no, we were talking and welcoming each other. So the top reason is because they want you to do the work on your own. They believe that communication between you will not happen efficiently. And they believe since you're doing the work alone, you don't really need to study for the midterm. So it's good for you anyway. I decided to be your partner. That's why maybe Jora, I can tell you how many questions you've been asking me for the past 24 hours. So I'm not that I'm complaining, Joe, but I'm saying that I'm ready to help you more than usual, you know, because I know you don't have a partner. I know it's time consuming. It takes a lot of your time, but Mark, you're still in lab number 2. And lab number 2, lab number 1 were so easy. What are you leaving for lab number 3? Let me tell you that lab number 3 is actually long, but it is exceptionally long. It's not like all the labs are similar, which means you'd rather find few hours every day or few minutes every day. Don't leave it all in one chunk. And let me help you. Like, I've never heard Mark asking a question. It's okay. We can discuss things together. I know where to answer and where not to answer, you know, because I need to grade you eventually. So yes, I can feel you, Mark, and I know that not being in a group of 2 could be awful for you. It's worse for myself. Okay, but I believe and I agree with the admin that it's better for you. Remember, you have a midterm in a few weeks. Maybe talk about the midterm next week and decide on a day. And then if you're doing the lab report, you don't really need to study for that midterm. Because what is a midterm? I will give you results. You do the analysis. If you know how to find averages and do linear regression and slope and so on, so you're fine. You don't need to study for it. Okay, so this is a practice. So the midterm is a mini lab report, or the lab report is a mini midterm. Okay, so which takes me now. Of course, Ratib, the midterm is very similar to the lab reports. We give you results, you do the analysis, you answer some questions. It's exactly like a lab report. And this takes me back to lab number 1. Maybe I want to discuss what I was expecting from you and what things affected your grades and what things did not affect your grade. And eventually, because I'm aware that this is a practice for the midterm, like eventually in the midterm, you have to present your work. The only tiny difference is the midterm doesn't have to be typed. So you can easily, the midterm is about the first 4 labs. Somebody was asking in the chat. So the midterm is lab number 1, 2, 3, and 4, along with lab 0, because lab 0 is the data analysis. So I was saying that in the midterm, you don't need to type it all. So you can write it all on a paper and take a picture or scan. And this is something you're not familiar with. Maybe some of you don't have an app to scan, or some of you do not know the size of the scanned file, and so on and so forth. So maybe at some point I need to give you a tiny assignment that is not graded, or maybe graded but so tiny that it doesn't take time. So you only make sure you know how to scan and send the work on time. Because believe me, those small technical difficulties will cost you a lot of time eventually in the midterm. Okay?
But won't we be doing it on campus, the midterm?
I will try my best. I will try my best. I hope so. But even if it's on campus, it has to be computer-based, because I believe some of the students will refuse to come on campus, and that's totally acceptable. So for us to make it fair for the people on campus and off campus, maybe if you come on campus, you can benefit from the internet connection, the electricity, and from me being around. But if we keep it online for everybody, like you do it on your laptop but on campus, to be honest, I don't know how it's gonna be, but we should decide very soon. Okay, Mark, any other questions before we start lab 1? Okay, lab 1, I have some questions and I want you please to forgive me to make this public, because you know some students would want to hide the grades, but it's okay, it's just a lab report. I want to ask, let me tell you, by the way, as you can see, I'm not done yet. Like Wisep Ali, I'm not done yet, but it's gonna happen today. Same with, okay, Jeff, I need to talk to Jeff. Is Jeff around? Crossing my finger to catch Jeff. If Jeff is not around, Julnar, please give me a few minutes to give you back your grade. So Jeff, I'm gonna email Jeff. I suppose Jeff is not with us. Is that true? All right, so let me go over. So I'm gonna go and fetch this one to give you a few like general mistakes you guys did. Okay, all right, it's loading. By the way, always take it as a habit to upload a PDF document. So I am actually giving you the results on a doc file, and I'm giving you the lab report as PDF and as doc as well. The PDF, you don't really need it. It's only there because it looks nice and it's good on your tablet or your smartphone, but you need the doc version to be able to edit, right? Because if you edit on the PDF, and yes, you can do that, you won't be able really to show a good presentation of a lab report. Like maybe the font will be different, the size will be different, the writing may not be on the same line as the writing of the lab report. I want you to keep in mind that this lab report will be eventually presented to a customer, right? Or to a patient, or to, I don't know, your boss. So it has to be an actual lab report. Okay, it's not something you fill in, it's not a scratch paper you do. So I'm happy that everybody had everything typed. You have the manual section. Do you see the manual section? You can keep it, no problem, but you don't need it, so you don't have to keep it. So how about you remove all this section and you start from here? I noticed that every single one in this class did not put any unit for the peak-to-peak voltage, and to make it even worse, time per division, period, frequency, all these, they need units. I know you assume it's the SI unit, but you have to say it, okay? Also, I believe those typings are not nice. And I mean by nice, definitely this will not be included in your grade, but I need to push you to present a reasonable lab report. It has to look like 5 times 10 to the negative 3. And you can easily use your Word, your Microsoft Office to show 5 times 10 to the negative 3 with a superscript. Very nicely done. If you have technical difficulties, please let me know. I'm willing to go online to share my screen and to show you how to do it. I'm not an expert, but I simply do it and I got used to it. Be careful with rounding. I noticed that a lot of students did not do any rounding. All right, so rounding and units for the first page. Compare the frequency. You already did the percentage differences, so you did the compare. Maybe you want to discuss it, and a lot of students did that. Comment. You were required to list the sources of errors. A lot of you do not know what sources of errors are, and it's okay because maybe we didn't talk about this enough. Errors are something we cannot control. A calculation mistake is not an error, it's simply a mistake. A faulty equipment, what is a faulty equipment? It means it's not functioning well. How about all equipment are functioning well, but they have limited precision? So an error is something that we usually neglect, like friction, but we know it's there. It limits, or it makes my experiment real and not ideal, you know? And every time you need to list the sources of errors, make sure that you give examples, like which instrument you're talking about. Like in this example, in this lab, you have the cable, you know, it has some resistance, so it takes energy out of your system and therefore affects the voltage or the whatever frequency voltage measured. You have the oscilloscope, you read on a screen, it's a graph, so it has limited precision. The small subdivision is 0.2 divisions times the scale. You have the function generator, the frequency knob, It has a limited precision as well. You can estimate the frequency. So these are three major sources of errors. What is the role of the vertical position control and the X? I know to move the signal to I don't know, move the signal up and down, right and left, but why do we use it? It has a purpose for a measurement, discuss that. Why should you maximize the size of the displaced wavefront? So 4, this is very important and nobody discussed it really well. When the size of the signal is bigger, the precision does not increase because the smallest subdivision is still 0.2, right? It's easier to read. I don't know, for me, it's the same. The only thing is that the uncertainty that is 0.2 divided by 2 divisions will be multiplied by the scale. So the smaller the scale, the smaller the error. That's it. It's not like a bigger signal is easier to measure. They are all as easy to measure because the smallest subdivision is the same. All right? Maybe you know that the precision is better, but you don't know how to say it. Because you know for small signals, the estimation you're doing is over 0.1 division, and 0.1 division is a lot in voltage, you know, in volts. So this is maybe what you meant, but you didn't know how to explain it. And what effect? Okay, this one was somehow a big mess for some, not for everyone. So when you change the scale, the Y, number of division, will actually change, but not the actual amplitude. Some students knew how to explain it, and some students talked about the measured amplitude, but the final amplitude. So try to name it differently. You know, how would you call it? The peak-to-peak voltage and the number of divisions. But anyway, it was okay. So this was an easy lab. Please use the doc file to fill it in, and then convert to PDF if you want before you upload. Because when you convert to PDF, you would make sure nothing would move. The table will keep on being the same, your graphs. Like now in lab 2, I think if it was not PDF, and I heard that some students were having difficulty. Let me go back to the main. I want to talk with a student called, let me tell you his name. It's a he. By the way, for some reason, the lab report presented by the girls were nice. I'm not trying to say I'm sexist, but maybe that was a simple coincidence. I'm gonna talk to somebody, and I'm sorry to make it public, to Mark Isa. Mark Isa is with us?
Doctor, he dropped the course.
Okay. Hopefully it's gonna update. Are you sure?
Yes, I'm sure.
Okay, I'm gonna email him anyway.
I will ask him to be sure. 100%.
It's okay. Yes, please ask him. Yes, please ask him. And thank you, Ludovic. I'm gonna email him anyway. All right. I think that's it. I have nothing else to say for lab 1. I'm sure that a lot of students did not check their grades yet. Do you have anything to say about lab 1? Okay, let's move.
Doctor, why is mine not graded?
Because I was too slow. So like I still need a few minutes. But I'm gonna do it today.
Oh, okay, thank you.
Okay, so
I thought
no problem.
it wasn't submitted.
No problem. Now talking about lab 2, I can see that Joe Boutros is not with us. I'm gonna email him. Hagop, is Hagop with us? I don't think so. We have.
Yes, doctor.
Hagop, what's wrong? I don't have lab 1 and lab 2 for you.
It's difficult from I don't know.
Are you not being able to upload? Do you want us to talk about it later privately?
Okay.
All right. So I'm gonna come back to you with an email, and if we need to meet, we can meet. Celine asked for extra time for lab 2. So usually I don't discuss this in public, but just for the first time to make it easier, because like most of everyone has issues, and it's okay. It's the same with other classes. Mark Isa, you told me I'm gonna email him. Jinnar?
I'm sorry, doctor. He dropped the course. He told me. I just texted him.
Okay, Mark Isa. Okay, Jinnar, are you gonna
Yes,
upload?
I will.
Okay.
Yes, I will submit. Just
okay. I'm just checking on you. Do you have difficulties? You're fine?
Everything's fine.
Do you have difficulties, Junnar?
But still, how do you relate your map to the strength of the field?
Okay.
So,
all right. So after class, maybe we can sit together and I can help you with it. Okay. And I want you to chill. It's okay. You can submit in the afternoon or in the evening. Okay. So don't stress out as long as you're working on it. Guisep, Ali, do you have difficulties in your lab number 2?
It's about a little bit.
Okay. Would you please email me after class so I can follow up on you in the evening?
No, I finished it, but it was a little bit hard. I was having some problems. I can submit it right now. I finished it 10 minutes ago.
Okay, awesome.
But I'm not sure about the answers. It was the...
Okay, take some time to review and let me know if I can help, okay?
Okay.
All right,
Thank you.
awesome. We're gonna start lab 3 if you guys are ready.
I'm sorry, can we submit?
Can we resubmit?
Of course. I actually opened the submission to make it unlimited, and I'm ready to grade once and twice and thrice. Okay?
Okay, thank you, doctor.
When you submit, though, I want to show you something. I hope it's gonna be clear. Let me show you. When you go to submit, I hope you can see my screen. You click submit, right? There's a section here, a comment section. Can you write in the comment why you actually submitted another time? Just for me to check the difference, because in some other class, students submitted twice the same lab report. It was exactly the same lab report. So imagine me grading both lab reports again, and it's the exact same lab report. They actually did it by mistake. So if you want to submit again, write me something about it. Write me that I modified this part, check it out, or anything you want, okay? It helps me, and if I believe you deserve a better grade, I can modify your grade, okay?
Okay, thank you, doctor.
All right. May I assume that's it? Now lab number 3, are you guys ready? Okay, what is lab 3? It is capacitance and the electric constant. I have a PowerPoint ready for us, but it's basically only to discuss the lab report. I'm not gonna take a lot of time on the theory, maybe discuss the theory through the lab report itself. Maybe I can tell you that this is grade 11 material, like you did capacitance back in grade 11. This is lab number 3, by the way. So what you need to know that the lab report is made of part 1, 2, 3, and 4. I just want to show you a visual way to see the lab report, just to be able to break it down. Part 4 is very short. By the way, they're not really related. Like you can do each part a day, you know? 4 is easy and short. 3 may take some time, but it has a lot of calculations. Number 2 is quick and it has propagation of error. So let me help you with every step if you need. Part 1, it has a plot, linear regression, find the slope, find the error on the slope, deduce epsilon 0, find the error on epsilon 0. Part 1 is actually really long. Okay, so part 2, 3, and 4 are tiny bits, but part 1 is a big section. So maybe do part 1, take one day for it, and 2, 3, 4 another day, or break it down over the week, okay?
Doctor, يعني part 1 it's a practice for lab 0 نعتبر.
Thank you so much, Antonio. You have a midterm in few weeks, which means you need to practice many lab 0 related material, all right? In the next lab 4 next week, you will practice a lot of averages and RMS. In this lab, you will practice a lot of linear regression, error on the slope, and propagation of error. So, Antonio, thank you for reminding me. Maybe you are gonna be frustrated from this lab report and it's a lot of work, but remember, it's your only chance to try those in an actual lab, you know? It's like next time, they're not gonna ask you about linear regression. So it's your only chance maybe before the midterm. Okay, so practice. So
I'm sorry, doctor.
Yeah.
You mentioned we have a plot in part 1. We can do it on Excel, yeah, right?
Yes. If you can see here, I have an appendix at the end that states, let's do this together. So I'm going to show you how I do this on Excel. And since the session is going to be recorded, so maybe in case you have Excel difficulties, you can watch it again. Worst case, I can meet during the week with you and I can show you again if you don't know how, but it's going to be easy. All right? And please, I beg you, everyone, just call me Jessie. Is that possible? Or Miss Jessie. That's the worst case. Okay.
Doctor,
Yeah.
Doctor, where we can practice for...
Yes, Joe.
Where we can practice for part 1, part 2.
Okay, I'm gonna show you now. I can help you, okay? So what is part 1 about? Part 1 is capacitance versus the plate separation. I'm gonna show you the movie of the experiment, definitely. Give me a few minutes. You will be given a capacitor like this one. You will have the two surfaces like a disc. What is the capacitance of a parallel plate capacitor? It's given by epsilon 0 A over D. Maybe I can ask Ludovic, what is D? Do you remember from grade 11? And maybe draw on the figure.
The distance separating the two plates.
Yeah, and how do you measure it?
English. I'm sorry?
How do you measure it?
I forgot.
If I ask you to measure a certain distance, how do you do it? Joe, how do you measure a distance?
I'm thinking on.
Tiana, how do you measure a distance?
Probably with a ruler. Is a trainer in this case.
Say it again.
A ruler.
A ruler, thank you so much. So you pick a ruler, a regular ruler, you measure the distance between the plates. The smallest subdivision divided by 2 is your error. So you will end up with 2 decimals when you say centimeter. And what is the area, Tiana? Which area are we talking about?
Of the plates.
Yes, it's the common area of the plates, and since the plates are facing each other, you find the area of this disc. Ali, how do you find the area of a cylinder? It's not a cylinder, it's just a flat disc, okay? How do you find the area of a flat disc, Ali?
It's the area of a circle.
Yes.
Pi r squared?
Pi r squared.
Okay, it's pi r squared. All right, so it's pi r squared. Did I hear to pi r? I'm gonna ignore it. All right, I need people to remind me epsilon 0 permittivity of free space, assuming that I have vacuum between the plates, which is not the case. So this is one source of error. I know that air actually is not a big deal, but it could be humid air, and the temperature of it may fluctuate depending on where I'm doing the experiment, on which bench. You know, there's one bench in the lab where the AC is actually really affecting it. So you can feel it. And all this is a source of error. Keep that in mind. What did I just do? All right, so anybody remembers the value of epsilon 0 from the course or from
8.85 times 10 to the power minus 12.
Okay, 85 times 10 to the negative 12. And the unit is? We don't remember.
C squared.
Let me say SI. No, it's not C squared. It's actually farad divided by meter squared and multiplied by meter. Okay, or just say SI units to say use it with SI units. Talking of SI units, let me tell you something. You will have to deal with picofarad for capacitance. The area is going to be in centimeters squared and the distance may be in millimeters. So it's going to be a big mess. Be careful about that. You can easily convert everything to SI to be on the safe side, or make sure you know how to handle the units well, and it's not difficult. All right? So in this experiment, you vary the distance between the plates and you measure the capacitance. That's it. The experiment is very easy. I have one thing to say though. You will be given an LCR meter. The LCR meter is very similar to a digital multimeter, but it measures L, C, and R. L inductance, C capacitance, R resistance. It's a very precise device. So you will connect it to the first plate and you will connect it to the second plate. And you will notice when you disconnect the two wires from the plates, it gives you a value that is not 0. Can you explain why? Maybe Ludovic can say something about it.
I'm sorry, doctor, it was lagging.
Okay, let me say the question again. So you measure using the LCR meter, you connect with a wire to the first plate, another wire to the second plate, and if you disconnect both wires, it does not give you a 0 answer, a 0 value. Why do you believe the LCR meter, when disconnected, does not give a 0 value?
There's still electron passing through the LCR.
No,
They will be charged. They will be charged.
By the way, your capacitor is neutral, and there's no battery, there's no circuit, no current, no voltage, no charge.
Oh.
So it's measuring the capacitance of something. What do you think? It's the capacitance of who?
The air?
No, because the air doesn't have, it's a conductor. It does not, it's not a good capacitor. The wire, thank you so much. Who was talking? Anthony, right?
Yes.
Okay, so Anthony, those wires, they do have a capacitance. Aren't they two conductors facing each other and you have nothing in between? So if you move them, the capacitance of the wires will actually change. The thing is, the capacitance of this capacitor is very small, picofarad. Picofarad is times 10 to the negative 12. So I cannot ignore the capacitance of the wires. So I'm gonna give you the capacitance of the wires and you have to minus this answer from each and every measurement you do in part 1. Is that understood?
Yes.
Okay, I'm gonna explain it again through the video. Now part 2 is so much easier. Part 2, you are given the same capacitor. You put a dielectric between the plates. The dielectric is a piece of plastic or a piece of cardboard. We're not gonna tell you the type of plastic, neither the type of the cardboard, which means your dielectric is an unknown. You measure the capacitance with the dielectric and without the dielectric, keeping D a constant. How do you do that? You insert the dielectric, you close on it. You don't push, you just close. Dielectric with, without, you measure with, without changing the distance between the plates. Okay? So C without the dielectric, I'm gonna call it C0. This is without the dielectric, is epsilon 0 A over D. A is not varied, D is not varied. And with the dielectric, let me call it D. So it's gonna be K epsilon 0 A over D. A is a constant, D is a constant. K is the dielectric constant. I need somebody to help me find K. How do you find K?
CD times D all over epsilon 0 A.
Yes, but I actually measured C0 and measured CD, and that's it.
CD over C0.
Yeah, isn't that faster to do? Although your method is not wrong, because you can take part, you find the area from part 2, from part 1, and D, you can measure it with a ruler. But since you measured with and without the dielectric, why measure the distance? And we're talking about few millimeters, maybe something you cannot see clearly in the naked eye. So if you do C with dielectric divided by C without the dielectric, you can find K easily. What is the unit for K?
Newton square.
It has no unit.
It doesn't have a unit.
It's the constant.
Why doesn't it have a unit?
Oh, they cancel each other.
We are dividing.
Yes.
The units.
So
They cancel.
yes, exactly.
We are dividing CD over C0.
Yeah, picofarad over picofarad will give you no unit. So Ali was the one giving me all these units, Newton squared, centimeter squared, right? Is that you, Ali? No?
No. Right now, no.
Maybe Ludovic?
No, doctor, I said no unit at first,
Okay,
but I said sorry.
All right, it was simply funny, and I believe it's okay. This person is like addicted to units because he's been giving me all units all the way. But I really want us to discuss units. That's very important. So K, and once you know K, can you guess what the dielectric is made of?
I guess if you know all dielectrics, maybe.
Yeah, so you actually can go online and try to find what the dielectric is made of, knowing the K of it. Now there's a question, if I'm not wrong, now that you know that K is equal to CD over C0. By the way, CD is measured with an LCR meter that is a digital measuring tool. Let me give you an example. Let's say CD is 492, okay? I think I need to type it because this is really bothering me. Picofarad. Can you please tell me what is the uncertainty on this measurement? It's a digital measuring tool. So what is the uncertainty? I can help you with it because we did not discuss this a lot. Yes, Tiana. It is
0.1%?
Yeah, it is 0.1 picofarad because for a digital measurement, you take the last digit to be the fluctuated digit. So you say 0.1. So it's like the smallest subdivision and you don't need to divide it by 2. So this one will have an
Doctor,
yes.
Miss Jessie,
Yes.
it's 0.1 to 10 to the power minus 12. No.
Yes, you can say 0.1 picofarad. Don't be fooled with times 10 to the negative 12. I know it's a very small value, but again, Antonio, the farad is a very big unit. So 0.1 times 10 or 0.1 picofarad is super small, but not as small as you can imagine. Like the farad is a big unit. It's like you're saying 0.1 picotons. Matons aslan is a big unit, you know? So picotons could be a reasonable small unit, you know? All right, but anyway, this is the measurement I did. I'm talking about this capacitor. Let me show you this one with the dielectric. So yes, our values are small. So we have to be careful with the calculations. All right, so C0 is also measured using the same measuring tool and probably you have the same uncertainty. Check the value and make sure it has the same unit. Now, how do you find the error on K? Who knows? How do I find the error on K? Like I have the error on CD, I have the error on C0, I need to find the error on K. Now, can you tell me the method and I do it for you?
I divide CD is error on CD over the error on C0.
No, please don't do that. We need to do propagation of error. Like the error will propagate to go to K and the error of C0 will propagate to go to K. And the propagation of error, since I have two measurements, you have to open the big parentheses, but because it looks like the Pythagorean theorem. Can you go back to lab 0? Do you remember seeing? Yes?
dk over dc
Yes,
d0
exactly.
times
So,
the error.
okay, let's do that together. Stay with me, Joe. So C0. So remember we did that in lab 0. Okay, and then so I need to do the derivative for each. I have two parameters in here. So this is dk. All right, maybe I need somebody and it's gonna be Joe to help me with the derivative. This is CD plus the error times the error on CD. And maybe fetch another pen. Let me use this one, but I need it thick so I can write quickly. All right, so how do you find the error of, the derivative of K with respect to C0?
CD.
Actually, it's like I'm saying C over X. How do you find the derivative of C over X? Because C0 is in the denominator, that's your variable. What's the derivative of C over X?
Minus C over X squared.
Yes, so I'm gonna do CD. I'm gonna ignore the minus because I need to square it eventually, divided by CO squared. Okay? And how do you find the derivative if CD is your variable, which means X over C0?
1 over C0.
It's gonna be 1 over C0. I'm sure there's someone or many students who did not understand this. Please speak up. You guys are fine? So let me say it again. We have a function. You're good, Anthony?
No, I'm not.
Okay, so I have a function that is K to be A over B. I need to do the derivative. I take A to be my X, then I take B to be my X. So if I have A over X, the derivative is A over X squared with a minus. And if I have X over B, it's gonna be 1 over B, the derivative itself. So I'm gonna do the derivative taking one measurement at a time and multiply by the error on it. Okay?
what I did not understand is where did we come from with the CD, the first one.
This one, this CD you're saying?
Yes.
Okay, it is your actual constant, because isn't this equal to minus C over X squared?
True.
So it is your constant. You cannot ignore it. Like you have CD over C0. C0 is the variable. It's like you have a constant over X. So you have to keep the constant. You cannot get rid of it. Antonio? You're not sure about it?
Not really.
All right.
The decay. I saw the decay. So I try to relate it.
So dk means the derivative of the function k. I want to show you something to give you a hint as a reminder. Maybe I don't remember which one. Let me try this one because it's basically the same thing. I just want to show you something we did. Hopefully it opens quick. Where is it? It was not on PowerPoint. Okay, but anyway, it's gonna come. Okay, continue. It was a keynote. By the way, somebody, all right, Hala, I'll tell you later. So this was slope related. I want to show you something. Is that it? Try this out on your own. You remember this one? Like we did R, U over I, and then this is exactly the same example. We did propagation of error, but I have R to be U over I. Okay? Anyway, think about it, go back to lab 0 and let me know if you still have difficulty. I'm ready to do it again. All right?
I will.
I'm gonna minimize it, and this, I'm not done with it. Like we're gonna come back to it, maybe face to face, and let me know if you have any question. So that's it for part 2. You would just be given C0 and CD, you find the ratio, you find K. The only thing that would take you time is how to find the error, but you're not asked to do anything else. Part 3, I wish we can do it in the lab because it's really experimentally nice. You will be given a box of capacitors. You pick 3 randomly. You write what's written on them, like you will be given. Let me type and enjoy typing. Okay, so they will ask you about the nominal values. Nominal values. What is the difference between nominal value and measured value and calculated value? Anybody? Yes? What is a measured value to start with?
The value we obtain in the measurement.
Okay, so the value given by the measuring tool. Given by the measuring tool. Okay, measuring tool. All right, the measuring tool here is gonna be my LCR meter because it does measure C, and this is what I want. And the nominal value is what's written, what is written on the box. On the box. Like for example, I will find a box of capacitors. C1, you can read 0.47 microfarad. This is written on it. And what I mean by written on it, maybe it's something to be trusted or not. If I measure it, the measurement will be very close to the value written on the box, but not exactly the same. The nominal value usually is not to be trusted because those capacitors are usually manufactured in gross, you know, like Ludovic, please mute yourself. There's a background noise. So maybe my interference of my voice. So the nominal values are not to be trusted because you know, you can buy them in quantities, those capacitors, and they say it's like 1 microfarad, but this is not precise. And you can see the nominal values, they basically have 1 or 2 significant figures and that's it. But the measured value, you can go up to 4 significant figures depending on the scale chosen. Now the calculated value, if you do any calculation, okay? Like here, they want you to pick C1, okay? Write what's written on it, nominal value, measure it. Pick C2, what's written on it, measure the value. Pick C3, what's written on it, measure the value. Then combine them in series, C1 and C2, do the measurements, and do the calculation. How do you calculate C equivalent if C1 and C2 are in series?
1 over C equivalent is equal to 1 over C1 plus 1 over C2 plus 1 over Cn.
All right, so you simply add the inverse of the capacitance to find the inverse of C equivalent. So you will calculate C equivalent and you measure C equivalent and you compare. How do we compare? If they ever ask you to compare. So my question is, they ask me to compare, what do I do? I calculate the
Ratio.
the percentage.
Experiment.
The
Yes.
percentage
Yes.
difference, yes. So Joe is saying experimental minus theoretical over theoretical, right?
Yes, yes.
Yeah, times 100. So basically we take one reference, which is basically the calculated value, and you compare the measured to the calculated by finding the difference. It's an absolute value, by the way. You divide by the reference and then you multiply by 100. If it is less than 5%, you can say accurate. Usually it's greater than 5% and it's still acceptable. 10% is okay, 20% is not okay, but sometimes acceptable depending on the equipment we have. Some equipment and some procedures are not very precise, but usually with circuits like these, you should be below 5%. I hope so. Okay? And if they ever ask you to comment, what do you say? Usually they ask, compare, comment. What do you say? For comments, we expect you to discuss accuracy like I just did. Also, you can list the sources of errors. All right, so from now on, when they say compare, you do this. When they say comment, you do this. Although in the lab report, we made it clear by saying comment, by listing the source of errors. But if we don't do that, you know what to do. Okay, so that's it for part 3. Shall I move to part 4?
Comment.
Yes.
My Wi-Fi just went out when you said what to do when they say comment. Can you just repeat what we do when they say comment?
Okay, I'm gonna do that, but first listen to Joe's question or Rudy's question, Joe's question. Whose question was it?
Mine, Rudy.
Okay. But someone else was asking something as well.
Yes, yes. I was asking about accuracy. Same question.
Okay, accuracy. All right. So what is exactly the question?
Mine was when they say comment, what to do, because I didn't hear, my Wi-Fi went out.
Yeah, and Joe, what was your question concerning accuracy?
I didn't understand how.
What is it? All right. So
That's it.
maybe I can go back to somebody's lab report and show you some accuracy related issues. Okay, I'm gonna randomly fetch anyone's lab report. Let it be Rudy. I'm sorry I'm doing that in public again. Usually I refuse to do this.
No, it's okay.
No, it's not okay. If I were in a medical school class, they would kill me for that. But again, it's a simple assignment. It's not like it's your midterm or something. All right, so I can see here, by the way, this is 6 significant figures. Don't do that. Don't do like Rudy. All right, this is 4.2%. When you see 4.2% difference, I'm actually comparing the frequency of the function generator to the frequency I took from the oscilloscope after doing all these calculations. The difference is 4%. It's not a lot. So it's below 5%. I would say my measurement is accurate. Accurate means close enough to my reference or to reality or to whatever value I have. So this is 13% error. 13% is not very close, like 2000 and 2200 or 2300 are not so close because the difference is 14% or 13.6%. So I would say this measurement is not very accurate. Do you see, Joe, what I mean? So accurate means close to the real value. Let's say that your temperature is 37 and I use a measuring tool and it gives me 37.5. This difference of 0.5, how much percent is it? Is it less than 5% or more than 5%? If it's less than 5%, you can say my measurement is accurate and okay and acceptable. But if it's above 5%, it's not accurate at all, and maybe throw it in the garbage. All right, so it's a way to check how accurate your measurement is. All right?
That's it?
Yes. Now going back to Rudy, no, not Rudy. Somebody was asking me, sorry, I have a very bad memory. Somebody was asking me about to repeat what's comment. I think Rudy. So every time they ask you to comment, you discuss accuracy. Like you say, this is less than 5%, what it means, more than 5%, what it means, and also list the sources of errors. And here, please give at least 3 sources of errors. Okay? So 3 would be enough. If you can see more, go ahead, but don't give less than 3. I'm sure you can find 3. Usually I can easily find 5 sources of errors. Okay? How do you see the sources of errors? When you watch the video, you would see the equipment. You would watch and see anything I've been doing that is not very stable. The measurement of the distance maybe is not super accurate because of, what do we call it? The parallax error. I'm not being able to see well. Maybe I cannot find the radius of the disk because I don't know where the center, so I'm estimating. Maybe there are a lot of wires and those will create some extra capacitance or some extra resistance in my circuit. So watch the experiment and then check what did you use in your calculation to tell where the errors are coming from. Okay? Errors are something I know they exist, but I can reduce them, but I can never get rid of them, you know? All right, maybe I can send you a list of errors in the announcements you can pick from. I don't know, I'm gonna think about it. Are we ready to move to part 4? I assume it's a yes. Yes, okay, so what is part 4 about? You would be given coaxial cables, these BNC cables, I'm sure you've seen them. And these are cables actually like 2 cylindrical cables, one inside and one outside. And between them you have an insulator. So this is the copper mesh outside, the copper wire inside. Outside you have an insulation, and in between you have an insulation. So the in between is called a dielectric. If you simply connect this one with the LCR meter, let me draw it for you. So this is your LCR meter. This is your cable, okay? You simply connect it to the LCR meter. Now, the thing is the LCR meter has 2 terminals. So you need a special adapter that looks like this. It has 2 legs. I'm gonna show you in the video to connect it to your LCR meter. And in this way, you would be measuring the capacitance of the wire plus the adapter. You can measure the adapter again alone to minus it from your answer. So you can measure it, you know, it's like 2 cables, but one inside, one outside. This is the equation for a capacitance of the BNC cable or the coaxial cable. You cannot use this equation anymore, this one. This is only for 2 parallel plates. This is for 2 cylinders, this one. C is the capacitance you measure. L is the length you measure with a regular ruler. B and A are the inner radii that are usually given to you. And K is the dielectric constant. You are given everything except K, and your job is to calculate K. Once you calculate K, you can guess what is the dielectric that is inside, and that's it. Oh no, you still have one extra thing. You will be given another cable, so you do that for cable 1 and cable 2, and then you connect them together, and you do it for cable 1 plus cable 2. Once you find C total by simple measurement, they will ask you, is that a series connection or a parallel connection? You would think it's a series connection, but it will end up being parallel, or maybe you would think it's a parallel connection, but according to the measurement, it will end up being series. How do you know from the measurement if it's a series or a parallel connection? Anyone? If I measure C1, I measure C2, then I measure C total, how can I tell if the connection is series or parallel?
I think we divide by 2. Nothing.
لا دكتور والجواب اللي بيطلع لنا من الفورمولا
بنثبت من بنجرب ال2 methods.
اوكي حبيت
بنحطها.
Okay.
Yes, what's wrong?
Okay, so we assume it's series, we do the calculation. We assume it's parallel, we do the calculation and check my answer. Is it closer to the series or closer to the parallel? In series, I do 1 over C total is 1 over C1 plus 1 over C2. In parallel, I do C total is C1 plus C2. And I check what is my final measurement. Is it series or parallel? I can tell. Do I make sense?
Yes.
Okay, let me check now the video, but I'm gonna make it quick because I know you can watch it later. I would like to take my time on the appendix, okay? So it was here, capacitance dielectric, just to show you quickly what I was referring to. So just the equipment quickly. In this experiment, we will explain. Okay, so this is the box of capacitors. We have a capacitance from Pascal of a variable distance between the plates, and you see each plate is made of a disc, flat disc, circular plate. You have the LCR meter. The LCR meter. So this is the LCR meter. So I'll tell you how to use it. This is a multimeter that you're not gonna use. These are the dielectric. Let me show you. So maybe you can compare both. You have some banana wires, maybe 4 or 5 banana wires. I don't know how many. You have some plugs for the LCR meter that you can use. You have the LC cables of different thickness, maybe. Yeah, and some adapters. Okay. As you may have noticed. Okay, did you see the BNC cables? Those, the black wires, these are the coaxial cables. And the adapters are on the table. Can you see them here? Oops, I'm sorry, I just moved it. Okay, let me pause. As you may have noticed, I want to show you the adapters. They are here. Do you see them? Maybe check them at the end of the movie how to use them. Let me show you how to do the connections. Okay, so I'm discussing the scale. Here I'm connecting to the capacitor in a moment. Okay, and I'm showing you how you can measure the capacitance of the wires alone. Wires are connected to the plates of the capacitor. Okay, as such. Okay, I show you one measurement. Then I disconnect to show you the wires alone. It will be a little bit different. By the way, the difference is not huge. We're talking in the picofarad, and picofarad is times 10 to the negative 12. Okay, let me show you now how you insert the dielectric for part 2. Sure that this is connected. Try to put it in here. Okay, push short. Okay, so I'm connecting, measuring. I should close on the dielectric. Do you see how I close the 2 plates on the dielectric? Such a way that you have no air between the plates. So you're not. And I'm gonna remove the dielectric to measure without the dielectric, without changing the distance. You see, without. All right, then I'm gonna start with this one. I'm gonna connect the C1 alone to one of the capacitors. And this one to this one. That the nominal values are written on the box, and the unit is microfarad. Again, microfarad is 10 to the negative 6. Picofarad was 10 to the negative 12. So this is 1 million times bigger than the values we were having. More, you know, I just want to be able to compare. Which means I will expect my SCR meter to change its unit automatically to nano or microfarad. It gives me 470.6 nanofarad, or something that could be 0.47 microfarad. Okay, do you see the 4 sig fig given by the measurement? And then I measure C2, and then I measure C3, and then now I need to try to connect them in series using those wires. So watch well to see how the connections are made, and then connect in parallel through the LCR meter, and so on and so forth. Now this is the BNC cable. Let me show you how I do with the adapter. If I may measure the capacitance of this cable, I need an adapter. So I'm going to take the LCR meter. I hope it's visible on the camera. I can use this adapter, connect it into here, and then connect the cable and make sure the cable is straight somehow, because you don't need to trigger some distance variation in this. So make sure your cable is elongated on the desk. Put your LCR meter on. Wait a second for it to give you a certain value. You see, it's 96.6 pico. All right, so basically I'm gonna do it for cable 1, cable 2, then attach both cables together. It's not gonna be difficult. And this video is around 15 minutes long. You can watch it to understand really what's happening. So I'm gonna remove the movie, the video I mean, and discuss the appendix. Yes.
When وقت نوصل 2 B and C cable بيصير عندنا 3 errors. The first cable, the second cable, and the digital هيدا measurement.
Yes. And you can maybe I would say limited precision of the LCR meter. I can say the limited precision of the ruler, because I'm using a ruler to measure the length. So I have 2 measuring tools here involved, 2 cables involved. And I would think also that the cable, if it's not super straight, maybe if it's curved or something, you can have a different value, no? It has to be straight. So this is also a source of error. Look at you. You just gave me 5 sources of errors. Well done. So now I'm gonna try to do this one on Excel. I'm gonna open my Excel. Yes. And show you how, by the way, can I copy paste those values? Wait a second, copy paste those values. I'm just gonna remove this. Yes, I hope so, because I hate typing. What's this? Okay, if I do this, what happens? Perfect. So what's those again? Maybe I can take a screenshot of this one, because I cannot keep on looking at least at the question. Okay, so I have C versus D. So where is my Excel? Here. Because I want to have one window. I don't want to jump. Picture. Yes. What's up? Picture. All right, meanwhile, this is C and this is D. I need to plot, you can see it on the screenshot, C versus 1 over D. So can you please tell me what is your x-axis and what is your y-axis? Plot C versus 1 over D. How do I proceed? What is my C, what is my x, what is my y?
C is my x, 1 over D is y.
Okay, so this is actually, do you all agree with this? All right, this is my x and this is my y. Okay, so when they say plot, they always, okay, so let me write it here. We say plot y versus x. Okay, so C is your y and 1 over D is your x. Let me make it a little bit bigger so we can keep it. I would like to put C on the other side, because I like usually to plot using a simple selection. So always have x first, then C. Select only the values and click insert, scatter, and pick the scatter that has no line. Okay? By the way, this is D and I just did a mistake. They want 1 over D. So how about I move this a bit to the side? Okay, delete this graph and calculate 1 over D before doing anything else. So no, D is not your x. 1 over D is your x. Okay, and to calculate 1 over D, I'm gonna do equals 1 divided by this, but I hope this is really a number and not a picture. Does it work? Yes, it does work. I'm gonna put my mouse in the corner and drag for it to do the calculation for all the values. Okay, and maybe have this a little bit closer, because why keep it far, and have it all centered and nicely, because I would really be unhappy not being able to see it well. All right, now I'm gonna take only the numerical values and insert chart again, and I can see a linear relationship By the way, we never had the chance to discuss the following, and I believe it's very important. I'm back to part 1. So if I have C to be epsilon 0 A over D, and if I ever ask you to plot C versus D, what do you get? Can you discuss the shape of the graph?
It's similar to 1 over x, or take 1 over x.
So it's gonna be a hyperbola. Excellent.
Yes.
All right, Ludovic, stay with me. If I ever ask you to plot C versus 1 over D, what do you get?
A line.
You get a straight line passing through the origin. Can you tell me what does the slope represent? So it's C equals something constant times 1 over D. What is this constant? Can you see it here? C epsilon 0 A over D, or C is epsilon 0 A times 1 over D. What is K? Anyone? Let me write
epsilon
it.
0 times A.
Hey, thank you so much. So K is all this.
Yes, doctor.
Yes, doctor.
Listen, I'm gonna continue recording. If you guys have anything and you cannot stay, I totally understand, because oh, it's still recording? Okay. How is that happening? Okay, is it still recording? I think so. All right, so I'm gonna say that I need to continue this. I believe this is very important. So unless you really need to leave us, leave, okay? But I think it's gonna take us around 10 minutes. So I'm back to you. You just told me that K, the constant, is epsilon 0 times A, right? So once you find K, you can deduce epsilon 0 by saying it's the slope divided by the area. Please do that. All right, now back to my Excel sheet. I just found the line, the plot. So can I assume everybody knows how to plot now? By the way, you can change the chart, how it looks like. You can make it blue. You can change the chart title. You can add, change the title of the axis title, primary horizontal, primary vertical, and increase the size and show it in a different color. Please do that. Then
Yes.
I want, yeah.
For the chart, you just put the values x and y, and you press on the chart. It takes the values automatically. I need to put them on there.
No, so you're so you're supposed to select your values. Make sure you have x first, then y. Insert, scatter. You click here. That's it.
Okay, that's it. Easy.
Okay, yes, it is easy. Please do it and learn how to do it. You imagine you're doing that on a graph paper. It takes forever. Then, and you can do that in the midterm. How pretty is that? Then you do right click and add trend line. Okay, so you pick linear and you click display equation on the chart. Then you display if you want the R squared value. Okay, and then I'm gonna remove this one because I want the whole window. I'm gonna take this one and double click, maybe select all, and do this, make it bigger for it to show. Okay, does it look nice? Are you being able to see it? So this is the slope. What is the unit? It's a big mess because your y-axis is still in picofarad. Your x-axis is 1 over millimeter, if I'm not wrong, or maybe centimeter. So I believe in this chart, going back to my appendix, they have some units for me. So D was in millimeters and C in picofarad. So be careful. The unit for the slope is the unit of y over unit of x. So be careful with what to do. So be careful. This is your slope and this is your y-intercept. That is basically very close to 0. This is in picofarad again. R squared will tell you how close you are to being a linear relationship. 0.99 is very close to 1, so this is a super linear relationship. So 1 plot C versus 1 over T, it's done. 2, do linear regression, find the slope, it's done. Now 3, find the error on the slope. How do you do that? Who remembers the equation for the error on the slope?
Error squared equals number of tries over number of tries minus 2 times sum of something. I forgot about this.
Okay, where do I find it? If you go to lab 0, not this one, there is in lab 0 the data analysis, the PDF file given to you. Let me show you where to find it. Okay, let me open the doc. No, it's okay. Let me move this aside. Okay, you can find it in red if I'm not mistaken. It's this one, and it says the error on the slope. Okay, so the error on the slope, by the way, slope is b, n over n minus 2. What is n? Can you remind me?
Number of tries.
So what is the number of trials in my case?
Number, how many times do you measure?
Yeah, it's basically here I have 5 cases, no? 5 points in the table. Okay, so what is EI squared? Who remembers? It's actually written here in the text. It's here. You take B, the slope. You find E1. You take B times X1 plus A is the Y-intercept. B and A are those, minus Y1. And there's a video, by the way, that I sent you for lab 0, week 2, if I'm not mistaken. I show you how I do it step by step. So slope times X1 plus Y-intercept minus Y1. I do E1, then I do E2, then I do E3. Okay, and then I need to square each and then add them up all together. That's for E squared. For delta, you do this. Xi, you add all the X together, then you square it. Here you square each, then you add them up all together. Since you're still beginners doing the error on the slope, in the lab reports you guys have, I already have it open for us. In the lab report, they give you a chart and they give you only 5 points. Like some other classes, we gave them 10 points, but we believe you are still beginners with this one. You show all your X, all your Y. They show you how to find Y1 and how to find E1 and how to do E squared, and they do it step by step for you, okay? By the way, this is your lab report. You will be given the values for C, you fill in the table, you do the plot, you do linear regression, and then you calculate epsilon 0 with your graph, from your graph, which is saying that epsilon 0 times A is the slope. Then they help you find the error on the slope. Okay? So that's it, I believe, yes.
In the table, when we calculate yi,
yes,
then we calculate ei. We use the value of yi rounded, or
okay, don't do a lot of rounding unless you have like 8 number of significant figures. If you have a lot of number of significant figures, round reasonably, but otherwise keep them all as is until the end where you round. How do you round? You find the error on the slope, you round the error, so when you see this error, this one has to be one significant figure, so you can round the error accordingly. Let me show you an example. Let's say that the error on this value is 0.1. You can keep it like as such. So it is 1179.4. If the error is so plus or minus 0.1, you can keep it like this. If it's equal to 1, then you have to round it to 9. You know? If it's equal to 10, then you have to round this to 80. You know, but I'm not gonna go further. If it's equal to, all right, so this is 79.4. If your error is 0.01, what do you do?
I round to 0.1.
1.794.
40 because you need 2 decimals like this one.
Oh,
So they should have the same number of decimals or ones or tens, you know? So you find the error first, you round your error to 1 sig fig, and then you round your value accordingly. So don't do any rounding throughout the lab report, keep it until the end, okay?
okay.
All right, I think I'm gonna break this question into 2 to make it easier on you. Like calculate the slope, calculate the error on the slope, then deduce epsilon 0 and the error on epsilon 0 and break down the points for you and help you through the grading, okay?
If xi have two significant figures,
Yes.
and yi one significant figures, we took the smallest.
No, please don't round in this table. Round your final answer only. This table usually...
To 1 sig fig.
Okay, listen. Usually, yes. Usually this table is hidden. We do it on a scratch paper. We want you to do it in the lab report just to be able to guide you. Okay? Nobody does this in a lab report. They usually do it on a scratch paper. So we don't care about the rounding you do, but we care about your final answer. Okay?
Yes.
Maybe I'm gonna write a note on top to say, no need to round inside the table, round at the end, your final answer. Okay, so I can remind you. Okay, so let me write a note for me, rounding question mark, and I'm gonna say, break this question down. Okay? So I remember to change it a bit before sending you the lab report. Cool? I think I'm done. I know you will have some questions during the week. I just have one advice for you. Make sure you don't do it in one shot. Like give yourself 3 days, not full days. Like maybe you can try a bit on Thursday, a bit on Friday, a bit on Saturday. So don't leave it all in one shot. If you need any help, I can meet with you or maybe help you through email. Okay? That's it.
Doctor, we don't have part B.
Bella, you have it all. Where's part B? This one? Oh, the
Yes.
bonus. Are you asking about this bonus?
Yes.
Okay, number 4, bonus. Do you think a dielectric has been used? So after you find the slope, you deduce epsilon 0. And once you have epsilon 0, you can tell, is it epsilon 0 like the one for vacuum, or is it K times epsilon 0? And you can tell if you have a dielectric or not. All right, so let me show you exactly what I mean. Do you see this equation? This equation states that this is your slope, or this is the slope. And you have the area, I suppose. Knowing the area, can you deduce epsilon 0? Otherwise, can you use this equation so you can tell if you have K or not? Like here you have K, but it's equal to 1. Okay, so what I meant in my bonus question, try to guess if you have a dielectric inside or not.
Doctor?
Yes? Yes.
So in a C1, it means that it's 1 cable, and CD for how many cables?
Okay, so C0 means capacitance without a dielectric.
The K that changes.
Yeah, K is the dielectric constant.
That's how many cables?
Say it again, your voice is low. I can't hear you.
K?
Okay, K is a dielectric constant. Okay, how do I find K?
How do we know from K?
Okay, listen up. I have an idea for you. What you can do is the following. Didn't we say that slope is equal to epsilon 0 times the area? So calculate epsilon 0. If it's equal to 8 point, it's written here. If it's equal to, it's written previously 8.85 times 10 to the negative 12, it means you don't have a dielectric. Otherwise, you have a dielectric. Okay? Because the dielectric, it's like you have K times epsilon 0. So you will have this instead. You see what I mean? If you want, forget about item 4, because I believe nobody will ask you about it. I don't want to confuse you. Like in your lab, they don't ask you this question. Check your lab out. In your lab, they just want you to find epsilon 0 and the error on it, and that's it. Okay? So don't worry about it, Hagop. It's really not a big deal to guess if there's a dielectric. In the lab, they tell you, in this case, you do have a dielectric. In this case, you don't. So don't confuse yourself. All right? So you guys, I'm done and you are dismissed. If you have any question, please stay behind. Otherwise, I'll be expecting questions from you over the week and let me help you with what you have, okay? So that's it.
Thank you.
Enjoy your day.
Thank you.
Be productive.
Thank you, you too.
Bye everyone, bye Ratib. Be productive and try to focus well.
Yes. Doctor, if we have submitted our homework, we can submit it another time with a comment, yes?
Yes, submit anytime you want. Write me a comment so I can consider your work.
Yes, yes. Thank you.
Okay, all right.
Question.